All right, we're simplifying algebraic expressions for the beginning of fourth quarter. You heard me in class today talk about terms and constants and like terms, and so I wanted to kind of give you an actual definition of this stuff. So if you take a look here, negative 4y plus 8 plus 2y. This is made up of three terms, 1, 2, and 3. The 8 is the constant. That's always going to be 8. These two here are going to change depending on what y is. Once I figure out what y is, I substitute a different value and it gets multiplied. Okay, same thing over here. However, these two ones in purple here are like terms. Those together can be combined to make something more simplified. So here are the actual word definitions here. A term is each part of an algebraic expression separated by an addition or subtraction symbol. So notice these are separated with these two additional symbols. Like terms, they must contain the same variables to the same exact power. Here's some examples. 2a squared and then negative 11a squared. Okay, don't get caught up with the number up front, the coefficient. Only worry about the variables. Variable a squared, those are like terms. This one here, also like terms. The 5 and the 6 doesn't have to be the same, but we look at the variable parts. X squared y. Both of them have x squared, both of them have y in the first power, so those are like terms. These would not be like terms. 3b to the third and 4b, because this is b to the third and this is b to the first, so no, they don't have the same exponent parts. Last word here is a constant. It's a term without a variable. That's just a number by itself, constant. All right, so example, identify the terms, the like terms, and the constants. All right, so take a look here. I've got 4n minus 8n plus 7 plus n. Okay, so first of all, I'll start with the terms. What do you think the terms are going to be? All right, let's take a look. Your terms should have been 4n, negative 8n, 7, and n, separated. These are four different terms. What do you think the like terms are going to be? 4n and negative 8n and n. Actually, there's three of them that are like terms. This one, and that one. They all have the variable n to the first power. Last but not least is your constants. There's only one that's a constant, which is 7. Coefficients. This just added extra part. Hey, what are the coefficients? If you recall, a coefficient is the number in front of the variable. So I look at the variables. It's 4, negative 8, and that ninja 1. So those are three different coefficients. All right, so here I wrote down, it looks like 8 or 9 different terms. I kind of just separate them all over the place. I want to know which ones are like 5x squared y. So take a moment to do that. All right, let's take a look. The first one, no, it's not, because it's not squared, so that's not going to be it. Next one, not squared, not that one. Here, x squared, yes. Y, the first, yes. That's the first one. Over here, x squared, no, so I had to stop right there. Back over here, x squared y, yep, those are like terms. X squared y, yes. X, nope, I need it to be x squared. Doesn't have x squared y. There you go. So those are the four terms that can be combined together. When you come across something that says, hey, simplify this algebraic expression, really what it's saying is, hey, you just need to distribute and combine all our like terms. Make it simplified. Get rid of parentheses and then combine everything that you can combine together. So let's take a look at this example. 10a minus 4 minus 5a plus 10. Take a moment and go ahead and simplify this algebraic expression. Type in what you think. All right, so let's see. This is what I would have done. I would have noticed that, hey, look, 10a and negative 5a, these are like terms, and so are negative 4 and 10. Those two together are like terms. This is how I wrote it here in the book. I wrote it out, and what I decided to do is I flipped these two around. I said, hey, these two, let me just switch spots for you a second. Why? So these two are next to each other, and then I can just focus on the 10 and the 5, the coefficients. 10 minus 5 is 5, and then I have a, okay, because 10a plus a negative 5a is 5a. Then these two are together next to each other, so negative 4 plus 10, that's positive 6. And that's it. I can't go any further. I don't write that as 11a because this one doesn't have an a, so I can't combine it. Let's take a look at another example. Try this one out first, and then I'll show you the answer. 3g minus 5 plus 11 minus 9g. All right, so the first thing I would have done is notice that, hey, right away, 3g and negative 9g, those are like terms. Negative 5 and 11 are also like terms. All right, so now that I noticed that, what I do is I go ahead and rearrange this stuff. And this is just in the beginning, all right, so that you can get more comfortable with it. So I rearrange them. I go 3g and negative 9g. Those are put next to each other, and these two are next to each other. I can combine these two to give me negative 6g and this to give me 6. These last two examples, I'm going to go by real fast, try to keep this video under 6 minutes. So here I'm going to distribute 3 times 4, 3 times negative 5, 4 times 2, 4 times 6. I distribute. I get this. I then combine like terms by moving some stuff around using the commutative property. Move these two next to each other, these two next to each other, and then combine them. I get 20x plus 9. My last example, what if I give you a perimeter and these are all the different sides? Well, I just add them all up together, right? So I look something like that. I then go back and combine my like terms. I say, hey, you know what? 4x, 6x, 3x, those are all x. I can combine that stuff. 3y and 7y, I can combine that. And that would be your final answer. All right, that's it for the videos.